Have you ever pondered over the current state of renewable energy and waste management? Are we doing enough, or is there room for improvement? As we traverse the 21st century, the importance of renewable energy is becoming increasingly apparent. With our planet's finite resources dwindling, the need for sustainable alternatives is not just desirable, it's essential. At the same time, we're grappling with a growing problem of waste management. Every year, billions of tons of waste are generated, much of which ends up in landfill, polluting our environment. But what if we could turn this problem into a solution? Imagine if we could take some of this waste and convert it into renewable energy. Sounds like something out of a science fiction novel, doesn't it? But it's not as far-fetched as you may think. In fact, researchers are actively working on this concept, and the results are promising. But what if we told you that chicken feathers, something considered waste, could be a key player in the energy game? Yes, you heard it right. Chicken feathers. But how is such a transformation possible? Imagine, if you will, the countless chicken feathers created as byproducts of the poultry industry. These feathers, often seen as waste, are actually treasure troves of a protein called keratin. Now, keratin is a pretty interesting substance. It's what our hair and nails are made of, but it's also found in abundance in chicken feathers. So what if we could take these feathers that would otherwise end up in a landfill, extract the keratin, and put it to good use? Sounds like a pretty neat idea, right? And that's exactly what a team of researchers from ETH Zurich and Nanyang Technological University, Singapore have been working on. They've developed a method to extract this keratin and turn it into thin fibers called amyloid fibrils. These fibrils are not just any fibers, mind you. They serve a pretty incredible purpose. They can be used as a semi-permeable membrane in hydrogen fuel cells. This is where it gets really exciting. These keratin-derived membranes are not only cheaper to produce in a lab setting than existing synthetic membranes, but they also show promise in the electrolysis portion of hydrogen energy production. By making use of a resource that is plentiful and usually discarded, we can potentially revolutionize the way we produce energy. Even better, we're replacing the use of toxic chemicals in the process. It seems unlikely, but science has found a way to transform these feathers into a component of hydrogen fuel cells. This, dear listener, is the potential of chicken feathers. Let's delve into the process. How do we get from chicken feathers to hydrogen fuel cells? Well, it all starts with the humble chicken feather. These feathers are composed mostly of a protein called keratin. Keratin is sturdy, resilient, and has the unique property of being able to form complex structures called amyloid fibrils. To harness the potential of keratin, researchers first need to extract it from the feathers. This extraction process involves treating the feathers with a solution that breaks down their structural components and releases the keratin. The resulting mixture is then dried, leaving behind a keratin-rich residue. This residue can then be processed further to extract the keratin in its pure form. Once the keratin is extracted, the next step is to transform it into amyloid fibrils. These fibrils are thin, elongated structures that are formed by the self-assembly of protein molecules. This transformation process involves heating the keratin under controlled conditions, causing it to denature or unfold. As the protein unfolds, it exposes hydrophobic regions that interact with each other, driving the self-assembly of the fibrils. Now here's where the magic happens. These amyloid fibrils, born out of chicken feathers, have a very special property. They can act as a semi-permeable membrane, allowing certain molecules to pass through while blocking others. This is the exact characteristic needed in a key component of hydrogen fuel cells, the electrolyte membrane. In a hydrogen fuel cell, hydrogen and oxygen are combined to produce electricity, water, and heat. The electrolyte membrane is crucial in this process, as it allows protons to pass from the anode to the cathode, enabling the generation of electricity. Currently, these membranes are made using toxic chemicals, not exactly the greenest solution, but with the use of amyloid fibrils derived from keratin, we can replace these toxic membranes with a greener, cheaper, and more sustainable alternative. The fibrils can be formed into a thin, flat membrane that can be incorporated into the fuel cell, replacing the need for synthetic, harmful materials. So there we have it, a seemingly simple process that holds much potential. While this process shows promise, it's important to acknowledge the challenges that lie ahead. You see, as it stands, hydrogen fuel cells are still largely reliant on natural gas sources for power generation. This reliance presents a significant hurdle to overcome, as it somewhat undermines the goal of creating a truly sustainable and renewable energy source. Moreover, there are other technical challenges to consider. For example, the production of these keratin-derived membranes, while cheaper in a lab setting, needs to be scaled up for mass production. We need to ensure that this process remains cost-effective and efficient at a larger scale. There's also the question of infrastructure. Wide-ranging adoption of hydrogen fuel cells would require a significant overhaul of our existing energy infrastructure, a task that presents its own set of challenges. However, let's not lose sight of the potential benefits. The use of chicken feathers in this way offers a remarkable solution to two pressing issues: waste management and the quest for renewable energy sources. Transforming chicken feathers, a waste product, into a valuable component for hydrogen fuel cells is an example of circular economy at its best. It's a way to reduce waste while simultaneously creating a valuable resource. The keratin-derived membranes also offer an environmentally friendly alternative to the toxic chemicals currently used in fuel cells. This could have significant implications for the health of our planet, reducing the environmental impact of energy production. Furthermore, the fact that these membranes are cheaper to produce than existing synthetic ones could potentially lower the cost of hydrogen fuel cells, making them more accessible and competitive in the energy market. And let's not forget the potential for job creation. Scaling up this process would likely require new factories and facilities, creating jobs and supporting local economies. Despite these challenges, the potential of this innovative method is undeniable. The journey to sustainable energy is not an easy one, but with innovative solutions like this, we're certainly heading in the right direction. So where does this leave us in terms of the future of energy and waste management? Well, the potential of this method is truly staggering. Imagine a world where energy production and waste management seamlessly intertwine, where one man's trash, or in this case chicken's feathers, literally becomes another's power source. This isn't just a far-fetched fantasy, it's a future that is closer than we might think, thanks to the ingenuity of scientists from ETH Zurich and Nanyang Technological University, Singapore. The extraction of keratin from chicken feathers to produce a semi-permeable membrane for hydrogen fuel cells could revolutionize our approach not only to energy production but also to waste management. The beauty of this method is its dual functionality. It not only offers a greener alternative to energy production, but also provides a sustainable solution to the disposal of chicken feathers, which have long been an environmental headache. The researchers have already applied for a joint patent and are actively seeking partners and investors for mass production. This is a promising step towards bringing this technology out of the lab and into our everyday lives. But let's not forget, this is still a developing technology. There are challenges to be met and hurdles to be overcome. For instance, hydrogen fuel cells still largely rely on natural gas sources for power generation. However, the breakthroughs made thus far are encouraging. They show us that with a bit of creativity and a lot of determination, we can turn problems into solutions, waste into wealth. These are the types of innovations that are going to shape the future of our planet. The application of chicken feathers in hydrogen fuel cells might appear unconventional, yet it's groundbreaking advancements like these that will mold the future of our planet.